Good afternoon or evening or morning, calculus people. We're in the integration unit. We're on day 4 today, and what we're going to look at today is integration using substitution. So it's kind of called the chain rule for integration. And we're only going to do the power rule in here. There are other ones. There's sine and cosine and all these other ones that we can do, but we'll leave that for the very, 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 very end if we get there in calculus. But we'll be focusing on the power rule mainly. Okay, so let me open my Blackboard up. And what we're going to do today is look at substitution examples. So I'm going to look at four examples of how you use it with the power rule. And basically, it's kind of like similar to the chain rule for derivatives, except in reverse because we're doing integration, going back to the original equation. Okay, so let's wait for our Blackboard to open up. We will get some background questions here. There we are, right there. And that's popping open. Okay, we'll hide this. And we will get what we're going to do today on day 4. Okay, so this is day 4 of integration, unit 6. And what we're going to be looking at today is pretty straightforward. We're going to be looking at the power rule, substitution, or chain rule. The substitution, sometimes called chain rule for integration. Okay, we're going to, and this will be for this will be focusing on the power rule. So it'll be an application. So that's what we're going to focus on, and we're going to do a few examples. Basically, we're going to look at various examples. Okay, and then again, I'll give you some practice time the next period kind of idea. Okay, so this is kind of similar to the chain rule in it. So what we have, I'm going to have to use a marker mainly here. We'll just get it set up here. We'll use blue today again. Okay, so if we go, say we're taking the integration of something like a large expression. If you have u, okay, du, like that, okay, this is going to equal the power rule one, right? So, I forgot to put the variables in there. Well, let's actually set it up a little different here. Sorry about that, guys. Let's just kind of get right into it and just pretend we're going to do a substitution. So let's look at, instead of stating a rule here, let's say we have something like this. Say we have integration of a complex 3 plus 2x squared, all in brackets, to the power of 3 4 dx. 4x dx, pardon me. Okay, so if we have a complex expression, we can use the substitution rule. So we say let u equal this material in the brackets. Okay, that is 3 plus 2x squared. Okay, and the reason we can do that because it works in a special case. If we take du dx, that's equal to, if we take the derivative of that, just the derivative of u with respect to x is, this is 0, and this is going to be 4x. So you notice it's right there, right? That's handy for us because there's some canceling. So then we rearrange. So that the dx is multiplied over to the right side so that we have it equaling du. Okay, so du is going to equal 4x dx. So now we can substitute this expression in for du there, and we can substitute this in for u. So we're going to be able to do a chain rule by converting the x into a u now. So our next step, so step 1 is to define a variable u. Okay, and then find what du is. Okay, step 2, find du. Okay, and then we can write the integral in a different variable now. So we can say that this expression, and then step 3 is to rewrite the question, the equation, in terms of u and du. Okay, so we know that this is u, so u to the power of 3, and this is du. So we can rewrite it as u to the power of 3 du, as this can be replaced with du based on what we know down here. Okay, so this only works with special cases like that, right? Okay, so then if we take and apply the rule in step 4 is to integrate. Okay, so we know the power rule, have to go backwards on the power rule. So that would mean we're going to get, when we do the integration here, we're going to get y equals, okay, u to the 4th divided by 4, right, plus a constant. Okay, now we have to just, step 5 is replace the variable. Okay, replace the u with the x. Okay, in this case, we're just going to plug in 3 plus 2x squared to the power of 4. So this is going to be y equals 3 plus 2x squared all to the power of 4 over 4 plus c. Okay, can't really simplify it anymore. We could expand it out, but that'd take a long while, but that's a good enough way to do it. So there's the first type of example. Okay, using the power rule application, okay, we have to take these ones here because it's raised to another power. We could expand the whole thing out and then just use regular differentiation, but it's easier to do a substitution for that particular one. So that was an example where we had a bracketed term raised to a power. Okay, and our second example, oops, on the wrong side here. In our second example, we'll do it on the next page here. We're going to do an example where, as soon as I get my bank up, in this example, we're going to have a product in there and it raised to a power. Okay, so, okay, and this is one where we're going to have to do some manipulation to get the du to work out nice and evenly. So in this case, we're going to do an example 2 here. Okay, substitution. And where manipulation, where you need some manipulation, where some manipulation of the equation will be used. To write out the equation is used in the equation. Okay, so let's say our example looks something like this. So let's say we have the integral of x squared times 2x cubed minus 4 to the 4th power. So we know we can't just integrate that, or there's no product rule or anything like that. We need dx. Okay, so we want to do that. So the first step is again to define the variable. Define v or u or whatever you're going to use. Okay, so that's going to be u equals 2x cubed minus 4. Okay, it's not going to be to the power of 4, it's just going to be that. Okay, so then if we go du dx, so step 2 is find du. Okay, so du dx, okay, this will be 6x squared. Okay, and then if we rearrange it, du equals 6x squared minus, or sorry, not minus, what am I saying? 6x squared times dx. Okay, you'll notice that is not the same thing. It's an x squared dx. So you'll notice that the du is 6 times too large. So in step 3, manipulate the du by multiplying or dividing, usually, to equal what's in the equation. Okay, so that's what we're going to do here. Okay, so that means in order to get x squared dx, we have to divide by 6. So du divided by 6, okay, is going to equal x squared dx. Now we have x squared dx. We can replace that in the equation. That's in the equation. We can use du over 6. Okay, so then step 4 is to rewrite the equation in terms of u. Okay, so in terms of u, I have to go, it's going to be, okay, this x squared dx I'm going to put at the end. So this is going to be my u to the power of 2, I believe it was. No, 4, pardon me. And then this x squared dx is going to be du divided by 6, right there. Okay, so now plus, now what I'm going to do is I'm going to remove, I want u du only, so I got to remove the number. So take the constant out in front. Step 4, move the constant out front. Okay, so I can move that 1/6. It's like 1/6, right? So this would be the same thing as saying 1/6 times the integration of u to the 4th du. Okay. Now we apply the integration. Okay, so we're going to apply the integration, keep the constant out front. One-sixth y equals 1/6. Okay, now we're going to go u, 4 plus 1 is 5 over 5 plus c. Okay, that's where we're at. Do some multiplying here. This would be u to the 5th over 30 plus c. And then we reintroduce the variable for our equation. So our variable for u is, what was it there? I'm going to go look back at the top here. 2x cubed minus 4. Okay, to the 5th power over 30 plus c. Okay, and that's going to be y equals, because we're going back to the original one. So that's our final answer in there. If you sometimes the book will write it as 1/30th times this number plus c. So sometimes if you're doing answers, sometimes they'll write it like this. Okay. Like that, or like this. Both are the same answer, no different there. Okay. Let's try a similar one. Okay, same kind of idea. We're still going to do substituting and manipulating. Okay, on the next page. Let's try this one. Let's say I have 8 x to the 4th minus 2, or 4x minus 2 to the 3rd power dx. Okay, if you want to pause there, you can try that one on your own. If you'd rather just watch me do another one, I'm going to do, this is dx, pardon me. Okay, so I'm going to do another one. You can pause and try it if you want, and then unpause. Okay, so I'm trying it, 4x minus 2. Okay, so then du dx equals 4, right? And then if we rearrange that into du equals 4 dx's. Notice we have 8 dx's, so what is the constant? This time we're doing a multiplication. So therefore, we're going to have to go 2 du equals 8 dx's. Right, we want that. And we got 1 du is 4, so 2 of them was going to be 8. So then we're going to rewrite the equation now. Okay, we're going to u to the 3rd power times 2 du's. Okay, and that's going to be those two there. Okay, and now we can do the integration. Take the constant out front to integrate u to the 3rd power du. Now we can use the power rule to work it out. Power rule would say this is u to the fourth over 4 times 2. Forgot the 2 here, right? Plus c. Okay. Pardon me, guys. So 2, we can reduce here. 2u to the fourth over 4 plus c. So it's 1/2 u to the fourth plus c. We reduce that down. Now we have to plug the x term back in. So this becomes 1/2 bracketed. The u term was 4x minus 2 to the power of 4 plus c. That's example number 2. Okay, let me check my time here and see how we're doing. Okay, that's about 20 minutes. That's not bad. We'll do our third type then. Who knows, maybe we'll even do practice today. We'll see. Okay, our third type of question that I'm going to show is with a root in it. Okay, when you have square roots in them. Okay, so we'll do that one next. Okay, so this is another example type 3 here of the substitution rule with roots in the equations. Okay, so let's say something like this. Let's say we have, let's go integration of x squared, square root of 1 minus x cubed dx on the outside. Okay, and we're going to follow the same process that we had before. We're going to just use this as our bracketed term. So u is going to be 1 minus x cubed. So du dx, okay, the derivative, is going to be 3x squared, or negative 3x squared, pardon me. Right, because that's 0 minus 3x squared. Okay, that's du dx. Now, if we want to write that in terms of du only, so du equals negative 3x squared dx. Okay, we don't have negative 3x squared, we have x squared only. So we want to convert this to, so if we want to convert it to a positive x squared dx, we have to manipulate it so that du over negative 3 would equal x squared dx. Okay, so this is what our substitution is going to be. We're going to sub the u in and this in for du. The u has to go in and the du in proper form. So we need these two things in there for our form. So then we have our expression, and when we sub it back in, we have a u to the 1/2, which is square root. Okay, du would be this would represent du over negative 3. We must take the negative 3 out front, put the constant out front. So therefore we would get 1 over negative 3 integration of u to the 1/2 du. Now we can use the power rule when we have this. We just have u to some power with du, where du isn't anything funny. So now we apply the power rule for integration, keeping the 1/3 out front. Okay. Okay, so the rule is adding. So this would be u to the 3 halves half plus 1 is 3 halves over, again, 3 halves up here, plus our c. Okay, so we have to do some manipulation here. We got a negative 1/3 and a 2 and a 3/2 here, and a u. So we got to be careful with our algebra. So then if we take it and we go, we'll keep the negative 1/3 out front, and we'll say that this is the same thing, and we'll divide, take the reciprocal and multiply when you're dividing. So this would be 2u to 3 halves over 3 plus c. Okay, took the reciprocal and multiplied. Now we can multiply this out to reduce it down. So this is going to be negative 2 u to the 3 halves over 9 plus c, or negative 2/9 if you like. Okay, and now we have to plug in the x value, which was 1 minus x cubed, back in for the u. So y equals negative 2, 1 minus x cubed to the power of 3 halves over 9 plus c. And that would be our final solution for y. Okay, so that gives us our substitution. There's 3 different kinds of substitution I did there. I did one with roots in them, one with where you have to multiply, and one where you have to multiply by a fraction or divide in them. And we did 3 or so different examples. We can do another one here. What do we got for time? Well, it's about 30 minutes. Okay, so let's go take a look at the practice work in this area. See if there's anything different that we missed. Okay, so let me pop that open here in a second. Oops, wrong page. Let me get to the right page for the assignment here. Okay, and I'll post this up, and I'll give you the rest of this period to work on it and next period to work on it as well. Okay, that's not bad. That's on the 11. Okay, so right here is what it looks like. This is in Word form, but I'll scan it in here for you guys on Chromebooks when I get a chance. We'll wait till it pops open here. Okay, so let me slide it over here. Okay, so here's some examples. Okay, maybe there's one here I can see that we didn't try a type of, that I'll maybe do one with these ones here with the negatives on the bottom. Okay, I didn't do any of those kind, but I will do one like that. Okay, everything else is fairly similar to what we did. Okay, we did an example like that. So let's try one. Let's try this number 11 here one. Okay, I did not do one like that for you. So let's do that example together, and then I'll give you that to practice. There's 18 there. You don't have to do all 18, but do some of them. So let's try one like this. Oh, it's not going to do it here. I'll have to write it out with marker. And so let's go back to marker. Okay, so let's try that one. 2x okay, and it really isn't that difficult, really. And this one is x plus 1 to the power of 2 underneath dx. Okay, so this one The real trick here is it's really nothing other than you have to change this to a negative exponent. So you rewrite it like this. 2x times x plus 1 to the power of negative 2 dx. Okay, and then there we have our, we can do our u now, right? So u equals x plus 1 du dx is equal to 1. Okay, so that means du equals 1 dx. Okay. Okay. Whoops. This is supposed to be squared. Otherwise, we wouldn't be able to do this one. I missed the square in here. So then let's do that, fix that up. Go back. This one wouldn't have been able to do because of the extra x in it. Put a square in there. I missed the square on the x. So let's do it over. So du is x squared plus 1. So then our du dx is a little different. So du dx is then going to be equal to 2x. Okay. And then if we rearrange this, du equals 2x dx, which checks off here. We don't have to do any manipulation on that one. So then when we rewrite our equation now, okay, we rewrite our equation as u to the power of negative 2 du. No manipulation needed because that's perfect, right? Okay, now that we've done that, we can apply the integration rule for y. So that means we add 1. So u to the power of negative 1 over negative 1 plus c. Okay, right? Add 1, and since we're adding 1, it's going down. So then if we substitute our variable in, y is then going to equal u to the negative 1 would be x squared plus 1 to the negative 1. And it's over negative 1, so we're just going to put a negative in front, right? That negative 1, anything divided by negative 1 is just a negative in front. And then we'll have, that's it for that, plus the c. Okay, so just in case we can't do one of those, good thing we looked there and did an example like that. So that's where we'll stop for our notes today. And there are 18 questions there. We got to that 35-minute range, which I don't want to go past. I'll post up for next day your practice assignment. You can start it today if you have the time, but it'll be up there tomorrow as well. And I'll give you a period to work on that. In terms of how we're doing in terms of content, if we want to look at the course, we have left to do definite integration and finding area using integration, area under the curve, and the handed. So we have 3 areas left. This is another 5-6 days or so of lessons, and including practice assignments and assignments. Might be a little bit longer than that. And that'll be it for calculus this year. And we'll talk about how we're going to do the final and things like that as well. See you tomorrow.